For lesson 7, we're going to work more with our reference sheet and our volume formulas to find the volume of a bunch of different shapes. So the first one says determine the volume of the composite shape below, and we want to round to the nearest hundredth. So we've got a cone, and we have a hemisphere. Our cone formula, 1/3 pi r squared h. So if we look here for our cone, we're going to have 1/3 pi, we have a radius of 5, and we have a height of 12. Now, to make this easier until I get to the very end, I'm going to keep things in terms of pi. So as I do this, and I plug everything into my calculator, I get 100 pi for my volume of my cone. Then for my hemisphere, 4/3 pi 5 cubed, and then I have to cut it in half. And same deal, I'm going to keep this in terms of pi until I get to the very end. So when I do that, again, it's going to give me kind of an irrational decimal. So I'm going to keep this as a fraction for now. So I'm going to take these two, I'll add them together, and I'm going to get a total volume of 550 over 3 pi. So if I take that and multiply it by pi in my calculator to the nearest hundredth, I get a volume of 575.96 cubic units. All right. The second one, a rectangular bathtub is filled 2/5 of the way with water. The bathtub has a length of 8 feet, a width of 3 feet 6 inches, and a height of 2 feet 8 inches. Determine the volume to the nearest cubic foot. So they give me my units in a couple different things here. So I want to put everything into feet. So 3 feet 6 inches is really 3.5 feet. 2 feet 8 inches is really 2.75 feet. So if it's a rectangular bathtub, it's really a rectangular prism. So we're capital B times h, which when we substitute in is length times width times height. So we have 8 times 3.5 times 2.75. And when we do that, we end up with a volume of 77 cubic feet. Now, I know in class, we didn't use just multiplying by 2/5, but that's because that was a pyramid. When it is a prism and it is filled 2/5 of the way, we know the volume is the same at all points because the shape is consistent throughout. So now, if we multiply this by 2/5, we will get a volume of 30.8, and to the nearest cubic foot, that's going to give us 31 cubic feet of water. For the third one, a cup in the shape of a right circular cone is being used to fill a bucket that is in the shape of a right circular cylinder. The cone has an altitude of 6 and a radius of 3. The bucket, which is a cylinder, has a height of 24, and everything's in inches here, so we're good, and a diameter of 20. Well, I know all my formulas here really have a radius in them, so I'm just going to cut that diameter in half to get my 10. So how many cups of sand? So the first thing we want to do is we want to find the volume of our cone. So 1/3 pi 3 squared times 6. And I can either leave this in terms of pi, it's kind of up to you, or you could put everything into your calculator at the same time. I'm going to leave it in terms of pi since I know both of them are going to have pi in them. Then my volume of my cylinder is going to be pi 10 squared times 24. So when I do that, I get 2,400 pi. So now if I want to figure out how many times you're going to have to fill the cone, we'll do 2,400 pi divided by 18 pi. My pi's will cancel out. And when I divide, I get 133.3 repeating. Well, how many cups of sand would fit without overflowing? That would be 133 cups.